First of all, what is meant by a differential equation? A differential equation is an equation that contains some derivatives of an unknown function. It is used in modeling physical problems to aid in the understanding of physical phenomena. Note that it is a fundamental tool to calculate the rate of change in diverse fields as economics, medicine, psychology, and operation research. Next, what is meant by radioactivity and carbon dating? It is known as radiocarbon dating, and it is a technique for identifying the age of an organic material using the properties of radiocarbon and radioactive isotope of carbon, which is carbon-14. As for our objective, the first one is we want to establish the first order differential equation and initial condition that can be utilized to figure out how an organic material is. The second one is we want to illustrate how a mathematical formula can be used to solve problems that are not related to the field. Our project scope is mainly focused on animals and plants as we offer a differential equation for estimating the age of deceased animals and plants.
Assalamualaikum, my name is Nurul Amaina. So today I will talk about our model. Our model is the first order differential equation, which is rate of decay, the n over dt equal to negative k and t. K is the rate of radioactive decay, and t is the number of atoms left of the time with the initial value problem, which is the initial amount of carbon atom equal to 100. Then we have to find the constant k by using half-life carbon 14, which is 5,730 years. So, when n equal to n naught at time 0, then nt equal to n naught over 2 at t 5,730. And then we have to multiply both sides with 1, and we will get k equal to 1.20968 multiplied with 10 power of negative 4.
For the manual solution, we have 7 steps, which are we separate the equation, we integrate both sides, and we apply exponential to cancel the loan. Then we change the constant e power of c into d to make it simpler. Substitute value of k and initial condition to find the d. Then we substitute all the known value into the equation to get a general solution. For computer aided solution, we just input the equation and get the answer same as manual solution. So for the graph, we have y-axis as amount of radioactive atom and x as years, and the graph is inversely proportional. For the discussion, according to the graph, the amount of carbon is inversely proportional by the years. As a result, we can observe that the amount of carbon has decreased through the time and starting constant when approaching 60,000 years. The percentage of carbon-14 left in biological materials is used to calculate their age by using its half-life concept, which are 5,730 years. So we assume that the carbon-14 might decay completely over time since it's remaining below 0.1% and difficult to detect. Thus, the graph above derived from the computer-aided solution demonstrate the link between carbon decay rate and time in years.
What we can conclude from this mini project is that the initial value problem is uncovered as the first order differential equation alongside initial conditions are established and by knowing the rate of decay. This method demonstrates how the quantity of carbon atoms changes over time by years and can be used to estimate the age of historical things discovered using rate of decay. Last one is mathematical methods are useful in a variety of areas, particularly physics and chemistry, since they make calculations easier for others to comprehend. For the recommendation to improve our model, the first one is to acquire an accurate result. The sample must be well cleaned because it could be contaminated by carbon-containing items such as the dirt that surrounds some bones or tests that contain animal-based adhesive. Second one is since the amount of carbon-14 are so minimal, samples older than 40,000 years must incorporate other elements such as potassium argon to boost the precision of the study results.